Good morning, everyone. I will present you the following subject: understanding the vibrotactile feedback of the electric guitar, methodology for physical and perceptual study. The present work is based on the vibratory analysis of an electric guitar, and we aim to clarify how the guitar player feels the vibrations produced when playing notes. When playing a musical instrument, the senses of hearing and touch are stimulated, respectively, by the sound and the vibrations of the instrument. For the potential separation of the sound production by the amplifier and the vibratory feedback by the instrument, we choose to study an electric guitar on different questions. What is perceived by a guitarist in the vibratory signal? Where is it perceived on the human body? And can guitarists make a difference between different vibratory signals on the guitar? Through these questions, we aim to develop a protocol to study vibratory feedback for instruments and link physical measurements with perception. It will prepare further work with modification of the vibratory response of the instrument. I introduced you the subject and its context. Now I will present you the proposition of protocol. Then I will discuss the progress and the preliminary results. Finally, I will show you our perspective with this work. We have imagined a 5 steps experiment with, at first, a modal analysis of an electric guitar, a Telecaster. The instrument is laid on straps in free configuration, and the excitation is provided by an impact hammer and a fixed accelerometer. In the second step, we measure the vibratory response to a peak excitation by a guitarist in playing situation with 3 accelerometers. The first accelerometer is fixed on the head of the guitar, where the actuator will be further placed to modify the vibratory response of the instrument. The second accelerometer is placed at an antinode of the 2 observed modes in the modal analysis that have the largest amplitude behind the neck of the guitar. The third one is placed near the thumb of the guitarist. Its position therefore varies according to the note played. The third step consists in the reproduction of the vibratory signal obtained in the previous step, but with an actuator excitation. The actuator we used is a small loudspeaker glued at the head of the guitar and weighs 30 grams. After that, we want to compare different signals we injected through the actuator. The signal recorded by the accelerometer in step 2, directly the signal of the guitar's pickup recorded in step 2, and use a sound synthesis of guitar plucks. We choose here a modal synthesis using the physical characteristics of strings, so length, density of material, diameter, Young modulus. Finally, the last step is a perceptual test where the musicians are asked to identify difference between the different re-injected signals in experimental conditions where several human body areas are masked, for example, the inner hand or the thumb. At the moment of the recording of this presentation, we made the modal analysis and we identified the modal parameters. The free configuration could be improved with spring rope, even if the difference will be weak. We measured the vibratory signal produced in playing situation with an attention on the experimental condition, not the same at the modal analysis. We assumed and observed low differences for the mode frequencies and only variation of damping. To reproduce the vibration with the actuator, we successfully re-injected the signal of the accelerometer near the end of the guitarist, knowing the transfer function between the location of the actuator and the location of the accelerometer. In the comparison of our 3 re-injected signals, the reproduction is similar to the situation of playing, and the spectrum of the re-injection with string sound synthesis signal is similar to the re-injection with the pickup recorded signal. The beginning of the test reveals the capability of guitarists to identify differences between the re-injected signals with the felt vibrations when playing, if the decay time is very different. An interesting fact is that the guitarists judged as more realistic vibratory signals, which finally look like the expected sound, hear the re-injection with the signal of the guitar's pickup of the sound synthesis. To go further on this experiment, we will do perceptual tests with an adaptation of the synthesis parameter to fit with the measured signals, especially with the decay time, offer the possibility to the guitarist to play with the addition of vibration, and we will observe the different reactions when masking some human body part, for example, fingers in contact with strings, thumb and palm hand in contact with neck, side in contact with guitar body. The experiment will be continued. Thanks for your attention.